Despite its small size, the Philippines is considered to be the fifth most mineralized country in the world in terms of gold, copper, nickel, and chromite. As of 2020, it was estimated that the Philippine mining industry contributed 102.3 billion pesos to the gross domestic product. Copper accounts for about 72% of the total mineral resources of the Philippines. Some of the major copper mining projects in the country include Didipo Copper Gold in Nueva Vizcaya, Carmen in Lutopan in Cebu, and Padcal Copper Gold in Benguet. However, one of the drawbacks of mining is the generation of acid mine drainage. AMD occurs when pyrite and other sulfate metals are exposed to the air, microbial activities, and water. 1 mole of pyrite, the most predominant metal sulfide in the soil, that undergoes oxidation can produce at most 16 moles of hydronium ions, making the surrounding environment highly acidic and increasingly laden with dissolved heavy metals. Conventional chemical neutralization is a common method, especially in metal sulfide mines where passive techniques are not applicable due to high acidity and excessive volume of AMD generated. Although effective, this approach requires a continuous supply of chemicals, manpower, and energy, making it unsustainable in the long term. Because of AMD's severe negative environmental impacts, researchers have developed promising prevention and remediation solutions. Active and passive remediation methods both work by raising the pH of AMD to precipitate dissolved contaminants, are currently considered the most practical option for treating AMD. This program aims to decontaminate the AMD from heavy metals and treat the remaining effluent to meet the DENR standard for disposal to bodies of water. The program has two project components. Project 1 will focus on developing bimetallic materials to recover copper, nickel, and zinc, while Project 2 will recover manganese and iron and treat the AMD to meet the effluent regulations of DENR. The main goal of the research program is to develop a novel and sustainable AMD management approach to recover valuable resources and, at the same time, treat AMD to standards acceptable to environmental regulations and water reuse for plant operations. Specifically, the program objectives are as follows: generate valuable magnetic ferrites from AMD, reduce and improve the quality of sludge generated by the HIFIP process, and treat AMD sustainably to environmentally acceptable levels.
The main objective of this component is to use a two-step neutralization ferrite formation process to improve the chemical precipitation or neutralization process. This proposed process is anticipated to achieve the following. Number 1 is the production of valuable magnetic ferrites, 2 is the generation of sludge with higher solids content, and 3 is operation at lower pH, which reduces the cost of chemical requirements. The two-step neutralization ferrite process was modified and designed to accommodate 60 liters of AMD per day. So this is composed of two subsequent pairs of neutralization and sedimentation steps. Materials for the vessels and tubings were selected based on their capability to withstand extreme pH conditions. The setup will also be installed at the project site in Toledo City at Cebu, where the source of the AMD wastewater for the trial runs will come from. Moreover, the bench kill setup will also be tested using the effluent from Project 1 in the latter part of the study.
Mining and mineral processing are important industries, however, they are being challenged by the impacts of wastes generated. Acid mine drainage needs to be appropriately managed for these industries to thrive sustainably while protecting the environment. The HIFIP program is expected to generate employment. Moreover, mining companies could ensure that their effluents are clean and will not pollute receiving bodies of water.